First thing, you have to make sure that you're using your data from one pass, one scanner only. You can check that in your if you turn on display settings and you turn on the individual scan mode. So now you can see here I have two scans loaded, and in order to better detect the distress, you have to use only one. And if I got a cross section, in my case I have a misalignment, but even if you have a really tight data, it's still better to use just one scanner, one pass, one scanner data. Okay, so once let me show points. So once I have the come up with the data, now I have to extract the painted stripes or any sort of lane boundaries. And here I already have some lines, so I'm not going to go through the process, but if you're not familiar, go to extraction by intensity tool, or trace and drape tool, or even break line extraction tool in order to create some of these lines, because for example this line is an edge of pavement, so you're going to need to use break line extraction tool to extract this line, for example, and these two can be extracted by intensity. Okay, so let me turn back to to color intensity, I mean the individual scans, and here in this case I'm gonna pick the scan with the highest density of a point, and it looks like I can just go here and measure the density of the point cloud. And let's see, so for my green scan it's about 51 square feet, 51 points per square foot, and for the red data set it's about 140 feet. So I'm going to use red data set for running the tool. So I can drag this over, and now what I can do is I can select this line. Well, I don't have selected first. I can just open the tool. Here is the rod condition tool, and all I have to do now is just select the lines and click process. First time I'm just going to run it with default options, and then I'm going to go through every single option to show what each option is capable of. So, but before I would like to explain how the tool is working. In order to do that, I'm going to have to go here and enable plot ground shots option. And if I click process, I'm going to have all my ground shots plotted. So these are all the ground shots the tool is taking into consideration when it's making a decision for a particular roadblock. So essentially what the tool is doing is it's subdividing the space between two guidelines into the roadblocks. So this is one roadblock, this is second roadblock, and so on. So for each individual roadblock, you're going to have two sub-blocks, which is basically if you divide your roadblock by half, those two sub-blocks are going to be considered individually. So for each individual sub-block, tool is going to select okay, so tool is going to select ground shots around the painted stripe and ground shots around the center line, and fit a plane to those shots using least square feet. So this is based on the assumption that nobody drives on the painted stripe and nobody drives on the center line, since those two surfaces are the best possible reference for the perfect road, so where the road was when they first built it. And so for each individual roadblock, you're going to have two planes, one plane for the right, where the right will go, and the second plane, it's going to be where your left will go. So these points will be used for right plane, and the points I selected earlier will be used for the left plane. So okay, once we know those planes, once we define those planes, we can come up with the way of telling what's going on in the particular roadblock. And let me undo this. And let me also mention that when the tool is going and sampling the data, it's also classifying every single point in point cloud it encounters. So every single point in point cloud will be classified based on the distance from the perfect road plane. So let's say here's an interesting area. Let me cut a cross section right here. And if I zoom in, so this my blue line is kind of correspond to the perfect road plane, plus or minus some deviation. And here we see the, let me bump up the weight, so we can see my gray points are plus or minus quarter inch from the plane, so I don't classify them. And my green points from quarter inch to half inch below the plane, yellow from half inch to 1 inch, and 1 inch and higher are the red dots, red points. So that's the way we classify them. And same thing for going above the plane. And it can be seen by default. You're gonna have this settings, layer settings. So within the plane will be gray, above the plane will be blue, brown, and magenta, whatever. So that's what's happening when the tool is running. And once it's done running, it's going to place icons for each individual roadblock. So for each individual roadblock, you're gonna have up to five icons, because we can identify 5 different type of distress at this point. And if you look at it right now, we can see there's green icon represents, triangular icon represents riding, and the green color represents the severity of the riding of the distress. So if we measure the distance from the plane to the bottom portion of the rod, it's going to be within from quarter inch to half inch. That's what the medium low riding corresponds to by ASTM standards. So, well, I can just place a straight line and measure the distance to the bottom of the rod, and it's about 0.47, which is a little bit higher than half inch, but since I placed my line just randomly, well, kind of higher than the data is, that's why we get this number. But yeah, this is what triggers the icon. So this deviation triggers the riding icon. So now let me show you different options that you can have. So let's start with the severity thresholds. So if you remember, here we had the green icon, and the rod is kind of deep. So I'm pretty sure I'm somewhere at the edge of between low severity and medium severity. So if I set my threshold, medium threshold, a little bit less, probably like 35. So let me. So this low threshold corresponds to the average rod depth which will trigger the icon. So from starting from this distance, we're going to have a green icon up to this distance below the plane. From 0.35 up to 0.08, we're going to have a yellow icon, and if the mean rod depth is bigger than 0.08, it's going to trigger a red icon. So let's see if we will be able to trigger yellow icon here, since I lower my threshold, medium threshold. And if I click process, here you go, we just trigger the yellow icon, since this particular area is deep, and its depth is at the edge between low and medium threshold. I mean, bottom medium threshold. And now, since we know how to change the threshold, we can do the same thing for low threshold, and let's say we set it to like 17, and run the tool. We should have some additional. Okay, so we have some additional icons. So we didn't have icon here before. Now we have the icon there, since the depth here is probably somewhere on the edge of low severity threshold. Okay, so that's, and we have similar threshold settings for potholes and bumps, and for corrugation as well. For pothole and bumps, you have same text boxes, since we're assuming that bump is basically pothole, upside down pothole. So we're using the same thresholds. And for pothole, you also have a diameter, which is well, simply by ASTM standards, you have to have depth and diameter in order to come up with the severity for pothole. And here are threshold for corrugation, same thing. So that's what triggers the green icon. That's what triggers the yellow icon. That's what triggers the red icon. So anything above those values will be triggered corresponding color of the icon and the corresponding severity. So I usually like to leave it on default unless you have to change it. But defaults have been working pretty good for many applications. So now next option will be plot distress info. This option enables or disable plotting over blocks. So here I have a regular way, and if I uncheck this and run, I'm not going to have anything. Pretty much only my point cloud will be classified. And if I check this and then check that, and move everything to unclassified layer, I'm going to just run the tool without any classification, and it runs a little bit faster. You wouldn't see where the routes are and stuff like that. So I usually like those on. Then you have another option, plot ground shots. We've seen what it's going to do. It's going to plot every single ground shot. Then you have a plot block labels, and what block labels are just simply the numbers. Number 1, 2, 3, and so on. And it's going to keep on going. For one DGN file, you cannot have those numbers repeating. You're going to have, so once you, let's say, select a different area, you want to run a tool on, it's going to start from 22. So it's going to be 23, 25, and so on. So you're not going to have repeating. So you can go back and find each individual labeled block. That's why we don't mix them up. Now, this is a very interesting option. This option enables classified ground shots to be plotted. So ground shots below and above the plane, under certain threshold, and upper and higher than the certain threshold. So let me run a tool, and you'll see what I mean. So now everywhere where the data is below the perfect road plane, the points, shots below the plane will be plotted. So this whole area is below the plane, and I don't see if I don't think I have any area. Okay, there is area above the plane. So if I undo this, and if I lower my threshold for the above shots to like 0.2, I click process. Yeah, here I have some shots that are above the plane. So, and okay, let me just also cut a cross section, so you can see it better. So now this area is below the plane. We have a red shots plotted, and this area is above the plane. This is, surface, and that's why I have blue points plotted. So that's what classified shots are. Let's go to second. Well, actually, we went to the second tab. Let's do the go to the third tab in the tool. Simply just you can specify the level you want to stick features to. So let's say for 3D icons, I have 3D icons like levels, but you can choose anyone and type a new one. And then layer option, by default, you're going to have the same as I do. So 18 through 24 will be your designated layers for point cloud classification. Then you have an option to specify the noise tolerance, and what this is going to do is, let me set it, let's assume I have no noise, so I set it to like really small value, and if I run a tool, it's going to produce some, oh actually, let me run the tool and then check this, and you're going to see some random noisy point clouds, shots, so like this area and this area, this area right here, this area. So that would, if you don't want to see this kind of stuff, you can just set it to like your noise level. So by default it's 0.2, but 0.01 is probably the best value for this data. And if I run it again, 0.01, I'm going to have a nice and clean result. So all my rods corresponding to the icons, and yeah, and I don't see so many isolated areas like this. Now, since it's pretty much it, maybe one more thing worth mentioning is that this values also triggers the volume threshold. So starting from this distance below the plane, everything that tool encounters will be combined and sum up to volume below, and everything that tool encounters above this distance from the perfect rod plane, it will be combined and it will be summed up to a volume above the plane. And you don't see the volumes at this point, but when you will be producing reports, you will see the volumes in the report. Right now, they're just going to be stored for each individual as metadata for each individual roadblock. And since we are pretty much done with road condition tool, let me open the report tool, and let me start with producing the actually, we don't need the point cloud anymore. You can turn it off or unload it, doesn't matter. Now all the information that we need is attached to the roadblocks. So for each roadblock will have metadata. And now what we can start with, running, let's do an Excel spreadsheet, and we're going to leave plot PCI info option enabled. I just want to show what it does. And here it is producing the report. And okay, so what plot PCI info option does is it plots this yellow dot, this text, and the outline for the sample unit. So based on STM64 standard, if all your selected roadblocks have to be divided by into sample units, which each sample unit is about 2,500 square feet. So this area is itself is about 2,500 square feet. That's why there is only one sample unit. But if you had an area right to the same side right next to it, you would probably have a 2 sample units outlined like that. And in this case, I have only one sample unit. And if I look at the report tool, at the report spreadsheet, I'm gonna have all my distresses summarized up here. So I'm gonna have riding low, and I'm gonna have 12 tiles, so 12 roadblocks. I'm gonna have low riding. Total area about 170 square feet. So this represents the affected area. For well, actually, this column represents the measurement for each individual distress. Some distress is measured in square feet, some distress is measured in feet, linear feet, some distress is measured in units, number of distresses. So let's say pothole is measured in numbers. So for this sample unit, I'm going to have 12 tiles with riding and 3 tiles with potholes. So I'm going to have 3 potholes, but since riding is measured in square footage, in square units, I'm going to have 170 square feet. And the way we measure it is if we go back to the classified point cloud. So what we do is we outline this area and measure it. So for each individual block, you're going to have area, affected area. So you can see this one is 16, and by the way, this is the number represents the area or the distress, affected area for the distress for each individual. So you can see this is 16, this is 32, 26, 17. It kind of makes sense since you have not so many green points, a little bit more, a little bit less, and so on. You can see it. And these areas are added together to get the final value. And based on this final value, we can calculate the density. So basically, this is the density of the distress. So basically, we divide this area by the total area of my sample unit. We come up with the then by the tables we come up with the default value, and using ASTM specified equations, you can come up with the total deduct values, and the total deduct value higher of the total deduct values, if you subtract it from the 100, it will give you the PCI index for this sample unit. So for this particular sample unit, we're going to have PCI index of almost 66 out of 100, which is I think it's not too bad. But now if we go to the index sheet, here we're going to have the same number, PCI value, and also here we're going to have volume below and volume above. So this is a cut and fill volume. Since we don't have any bumps, and well, there's a little one, but just but we don't have any bumps, and so we don't have any volume to cut. But we have ruts and potholes, and that's why we have about 4 cubic feet of fill volume. So in order to fill all those ruts and potholes, we have to have 4 cubic feet of asphalt or whatever. And here we have average PCI, sorry, and total volume below. So if you had many more sample units, let's say 10 or as many as you want, this will be your average values here, and this is the date. So that's what this Excel spreadsheet will do for you. Now, oh, by the way, this is a nice feature. If you want to run multiple distresses, multiple reports, you can select this all and click reset, and it's going to reset to the initial settings or initial view is going to delete all the elements, remove all the elements that were just created with the report tool. So now if we go and select next format, this is Rabix format. So simply this is a CSV output file, the produced CSV output file for the Rabix software. I'm not going to generate that. This is for people who specifically work with this software. I'm going to jump to next export format, which is a shapefile, and I'm gonna click generate a report, and you have to come up with a name. Once you come up with the name, click accept. It's going to do the same thing. It's going to plot PCI info if you have this option enabled, of course. And then if I go to my file explorer and which one did I just produce? And TikTok. And here are my shapefiles. So for the report shapefile, I'm gonna be having two shapefiles. One shapefile is for roadblocks themselves, and the second shapefile will be for those bounding boxes. And you can open them with ArcGIS or whatever software you're using. So here is the shapefile. Now next export type is writing only, and if I generate this demo one, save, and now if I open the file, here is what I'm going to see. I'm going to see my writing information in the spreadsheet. So I have block number. If you had your block labels option enabled in the road condition tool, you have this block number 1, 2, 3, and so on. And here we see the this is essentially your block label, block number. So for block number 2, which is this one, I'm gonna have writing with low severity. 1 represents low, 2 medium, and 3 high. I'm gonna have area, affected area in square feet, and then I'm gonna have GPS location, and I'm going to have average of the rod depth, minimum and max depth. So same for right lane, and yeah, and for each next block, I'm gonna have the same information. And those blocks are sorted in a spreadsheet in a way that if you start from here and end here, that's how you're gonna look at the date. So this is number 2. This is probably number 13. Then this is number 3. This is number 14, and so on. So you're going from left to right, and you kind of sorting your blocks along the guideline, along the line, going from left to right. It's not like you're going up and down and left and right. So this kind of way of sorting the roadblocks for a better visualization. So that's what the writing only will do. Now if I do the same thing but for potholes, and let's do pothole demo 1, and if I do the same thing for pothole, I'm gonna have pretty much identical report, but just for the potholes. So here I'm gonna have just the block ID, severity, yeah, and the GPS location, because that's the whole information I'm storing for the pothole. So if you don't want to know if pothole is there or it's not there, you just generate the spreadsheet and it will give you the GPS location and severity of the pothole. Okay, then if click reset, now this thresholds are kind of disabled because these thresholds are for cracks. We're currently working on the cracks, but cracks are not done yet. That's why this all area is disabled. And if I go to the second tab, here you can specify the levels you want to place your elements to. And yeah, I think that's it. Oh, let me actually go through one more thing that we are capable of producing, which is a light mesh. And for the light mesh, let me show you what you're able to do. So for the light mesh, I'm gonna have my plot classify ground shots enabled, and I'm gonna plot shots below, shots above the plane. Now I can just come up here and delete all my roadblocks. I don't need them. Okay, actually I'm just going to do this. I'm just going to select everything. I'm going to need the points, and I'm going to need my guidelines, and everything else can go. So I have this, and now I can open road extraction tool, and here I can just run it to produce road shots let's say every 3 feet, and data interval will be let's say 2. So let me run it, see. Did I get, yes, okay, so I got some ground shots from some road shots. So what I can do now is I can select my road shots, shots below, shots above, road shots, and I can produce the mesh from points. Okay, so mesh from points, here you go. So now I'm going to, okay, I think my mesh is in default level, but I can move it to, let's say block metadata. Okay, now I can turn off my default value. Here I'm gonna have only mesh left, and I'm gonna change it to a smooth, and here we go. So this is simply a mesh, it's a light mesh, but it's a very detailed mesh, since we are only using points, only using key points. So we're using points that correspond to area of the interest, right? So we can see all our potholes. Here we can see a little bit of rutting, another pothole, another pothole. So I don't know if you can use it for your application, but it can be done very easily, and it's really light mesh. So you can have your ground shots, you can have your road shots being at higher interval if you like, and just I don't know how many points I have. So if I undo this and select them all, I have about 1500 points, but it can be done with less points, since this area of interest is has really dense and really small grid for the parsing the data and placing the shots. Yeah, that's pretty much it. Thanks for watching.